Hello, friends. Welcome to another episode of your favorite algorithm channel. Today we're going to be doing LeetCode 20 valid parentheses. So let's introduce the problem. Given a string containing just the characters, these characters, parens, and curly brackets, and also square brackets, determine if the input string is valid. So an input string is valid if open brackets must be closed by the same type of bracket. So a paren must close a paren, a curly bracket must close a curly bracket, a square bracket must close a square bracket. And so I think it'll be helpful to just kind of carefully go through what's valid and what's not valid, right? So in this first example here, you can see it's just two parens, that's valid. Or just having them all lined up together like this is also valid. This is obviously not valid right here, right? This open paren and this closing square bracket, they don't match up together. And I guess this is maybe one that could potentially be kind of tricky, where you have two parens kind of sandwiching each other. You can't do that, right? They have to be nested. So like in this last example here, like these are nested. So this is valid. So as always, I encourage you to do this problem on your own. And then come back and check out the video solution. But if you're ready to get started with this, with LeetCode 20 valid parentheses, come with me to the whiteboard. On the screen here, I have drawn a string. So this is the string that we're going to be processing. So the example problem that we're going to be working with, and I've drawn this pairs object that we're going to be using to just track to see if the brackets are matching, if they're a pair. And then I've also drawn this kind of representation of a stack. So let's go through the different parts and talk about how they're going to help us solve this problem. Well, what's the main problem, or what's the most difficult part about this problem? Well, the most difficult part about this problem is the fact that this string could become a very deeply complicated nested structure of brackets, right? And to keep track of all of what brackets we've seen, what's the last opening bracket that we saw to compare it to the next closing bracket, well, that's going to be that could potentially become very complicated, right? So using a stack is going to be very helpful to us in keeping track of that information. So the way that a stack works is so it's first in. All right, let me get this right. So it's first in, last out, right? Or last in, first out, right? So the only item that we can ever compare it to is the item that's on top, which is the last item that we've seen, right? Which is what we want to do, right? We want to go through this string, and when we get to this character, we want to be able to compare it to I found a closing bracket. What's the last opening bracket that I saw, right? And a stack is going to help us do that because it's going to be the most recent thing that we've seen. So, and then with this pairs object here, well, we can only ever decide if a pair of brackets is valid if we come across a closing bracket, right? So we'll check this pairs object to see is the current character that we're looking at, is it a closing bracket? If it is, we can then check its pair, right, to see, okay, do these match with what's on top of the stack, what's the last opening bracket that I saw. So let's go through a round of solving this problem, and I think you'll see how using this stack and this pairs object is going to help us to solve this problem. So we're going to start at the first index here, and we're going to check to see, is this character a closing bracket, right? Is it a key in our pairs object? Well, it's not, right? So we can't do anything with it right now, so we will push it onto our stack, and we'll move on to the next character in the string. So we will again check to see, is this a closing bracket? Is it a key in our pairs object? Well, it's not a key in our pairs object, right? So we can't do anything with it. So we will push it onto our stack. And we'll move to the next item. So we'll check to see, is this a closing bracket? It is not, right? It is not a closing bracket. It's not a key in our pairs object, so we can't do anything with it, and we'll push it onto our stack. And so we will now check to see, is this next character in the string, is it a key in our pairs object? Well, it is, right? It is a closing bracket. It's a closing square bracket. So now we can check so now what do we want to know? We want to know okay, we found a closing bracket. What is the last opening bracket that we've seen? Well, that's going to be the item that's on top of the stack, right? That's going to be the last opening bracket that we've seen. So now we can check to see, does the value to this key, this closing bracket, which is this opening square bracket, does it equal what's on top of the stack here, right? And it does, right? So they're equal. So we know that that's a valid pair, right? So we can pop that off of our stack. We can eliminate those two. We know that that's a valid pair, and we can move on to the next item in our string. So the next item in our string is a closing curly bracket, and it is a key in our pairs object. Its value is this closing or opening curly bracket, and we can compare to what's on top of our stack. These two values are equal, so we know that that's a valid pair, so we can pop that off the stack. And we'll move on to the last index in our string. And we'll check to see, is it a key in our pairs object? It is a key in our pairs object. Its corresponding value, we can compare to what's on top of the stack. What's the last opening bracket that we saw that we haven't matched up yet? And that's going to be this opening paren, right? And they are equal, which means that we can pop that off of our stack, and we're done, right? So our stack is empty, which means that every single character we've come across has had a corresponding, every opening bracket has a corresponding closing bracket, meaning that it is a valid string. So at the end, what we can do is we can just return that the stack dot length is equal to 0, right? If the stack length is 0, then that means that there are no characters left. Everything has a matching pair. And if there are items left in the stack, well, that means that those items didn't get matched up with anything, meaning that it's not valid. So now that we've seen how this can verify a valid string, let's just go through a case where it is not a valid string, just to prove to ourselves that this works in both cases. Okay, so I know what you're thinking. You're thinking, hey, Ryan, that last example was super easy. I'm not totally convinced that this actually works. So I've gone ahead and drawn something slightly more complicated, kind of random. And we'll just go through really quick. I won't go through matching everything up. We'll just kind of visually do this process just so we can see it working, right? So we'll start off at this first index here. This is an opening paren. It's not a closing paren, so we'll just push it onto our stack. And we'll move on to the next item. Well, it's a opening paren, so we'll also push it onto our stack and move on. This is an opening paren, push it onto our stack. And this is an opening curly brace, so we'll push that onto our stack. We'll move on to the next item, and this is a closing curly brace. So we can look at the last item in our stack, and we can see that this is a matching pair, right? This closing curly brace does match up with this opening curly brace, so we can wipe that off the top of our stack, and we can move on to the next item here. This is an opening square bracket, so we want to push that onto our stack, and we'll move on to the next character in the string. This is a closing square bracket. We can look at the top of our stack, and we can see that these are a matching pair, right? So we can wipe that off the top of our stack. And we'll move on to the next item in the string, which is a closing parenthesis. And we can see, if we look at the top of our stack, that these are a matching pair, and we can wipe that off the top of our stack as well. Move on to the next string, opening square bracket, push it onto the stack. Next character in the string, opening curly bracket, so we'll move that onto the stack. Next character, opening paren, move that onto the stack. And then the next character is a closing paren. Look at the top of our stack. This is a matching pair, so we can wipe that off of our stack. Again, these two match up, the curly brackets, so we can wipe that off the top of our stack. And we'll look at this. It's a closing square bracket, matches the top of our stack, and we can wipe that off the top of our stack. And then we'll move on to this here. So we'll take a look at this. We'll see this is a closing square bracket. And we'll look at the top of our stack, and we'll see that it is in a corresponding position to an opening paren, right? So this is not a valid string. This is not a valid string because these two brackets do not match up with each other. So we could actually just right here just return false, right? So we know this is false. We can return false. But we could also handle this by pushing it onto the stack, right? And just going through the rest of the string and pushing those onto our stack. And at the end, we could just return the stack.length, right? So you can handle this either way that you want. You can either just short circuit the problem and just return false as soon as you find a pair that doesn't match up, or you could just push that onto the stack and just return the stack.length at the end, however you want to deal with it. And then, so now that we have, okay, so let's go over the time complexity of this problem. So what's the time complexity of this problem? Well, the time complexity of this problem is big O of n, right? In terms of the length of the string, right? So that's a big O of n in terms of the length of the string. But what about the space complexity? So this is the time complexity. What about the space complexity? Well, we're using a stack to keep track of the opening brackets. What's the last opening bracket that we saw, right? So what would that be? What would the space complexity be using this stack? Well, you could envision a scenario in which the entire string is composed of just opening brackets. So that would be a space complexity of big O of n, right? In terms of the length of the string, right? Because we could potentially just shove every single character in the string into the stack. So the time complexity is big O of n, and the space complexity is also big O of n. So now that we have seen how this, we have a good handle on how this algorithm works, let's see what it looks like in code. I've gone ahead and added in the brackets object that we're going to use to be comparing the different sets of brackets. And now we just need a stack, right? So to represent our stack, we're just going to use an array. So an array, we can do push and pop. We can look at the last item. Those are the things that we need to do. So an array will work for our purposes. And then the next thing we want to do is we just want to loop through the string. So we'll just let I be 0. And while I is less than the length of the string, then we'll just increment I. So we want to look at two things while we're incrementing through our string. We want to look at the current value, which is just going to be s at I. And then we also want to look at the top of our stack. So the top of our stack is just going to be equal to the stack, the last index, right? So that's just stack.length minus 1. So now we have the current value and the top of our stack. So we just need to check now. We just need to say, okay, so if the current value is a closing bracket, or if it's not a closing bracket, we just want to push it onto the string. So we can just say if not brackets current, right? So if not, if the current bracket, if the brackets object does not have a key that is the current character in the string, then we just want to push it onto our stack. So we can just go stack.push current. And if it does have that key, so if it is a closing bracket, then we just want to check to see if its value is equal to the top of the stack, right? So we just want to say if top is equal to brackets current, so its corresponding pair, then we want to pop that top value off the stack. So we'll just say stack.pop. Otherwise, we can just push it on. We'll just say stack.push. And that should be everything we need to do, right? We won't short circuit. We'll just push it onto the stack. And then at the end, we'll just say, we'll just return not stack.length. So if we say not stack.length, that means like not 0, right? So that means if it's 0, it will be true. And if the stack has a length greater than 0, then it will be false. It'll be not true, right? We're negating 0 for our truthy value and negating a truthy value to be falsy, right? So let's just do a quick recap here. We have our brackets object that has our corresponding opening and closing brackets. we have our stack here that's keeping track of all the opening parens that were in brackets that we're coming across. We're keeping track of our current value, and also at each iteration, looking at the top of our stack. So if the current bracket is not a closing bracket, then we'll just push it onto the stack, right? And otherwise, if it is a closing bracket, we'll check to see does the corresponding value to this closing bracket is it equal to the top of the stack? If it is, then we'll pop that value off. Otherwise, we'll just push it on. So I have a typo there, so we'll just push on the current value, right? And then at the end, we'll just check to see, is the stack empty? All right, so as you can see, I have done this before, did this 8 days ago, did this 7 months ago. But we can just take a quick look at the distribution. But this problem is fairly straightforward in terms of the optimal complexity, right? To be able to check if all these parens are valid, we do have to look at every single character in the string. So a runtime of big O of n in terms of the length of the string is going to be our optimal solution. Now, there is a way to optimize this problem, I believe, without using any extra space. I didn't want to do that because it's a little bit more convoluted and hard to keep track of. And I think that this approach using the stack is a very clean and easy to reason about way to solve this problem. Anyways, I hope you enjoyed this video, and I hope to see you in the next problem.